Now let's take a look at this figure 14-13 and see what the actual speed of a motor would be based upon the slip. Now notice our motor, we have a 4-pole motor with 5% slip, and it's 120 volt, 60 cycle motor. Now, step 1, we're finding the synchronous speed. So the synchronous speed is 120 times the frequency divided by the number of poles. So 120 times 60 divided by 4, 1800 RPM. Using the alternating current, then the synchronous speed would be based upon the cycles times the frequency and the pair of poles. So we'd come in and run the synchronous speed, 60 cycles times 60 cycles divided by 2, 1800. And we see, yeah, that would work out, see. But now, step 3 is where we're going to find out what the actual speed of the motor would be based upon the slip. Remember, it never can catch up with the magnetic field. It'd be like the demonstration. You have a girl running, say, another girl trying to catch her. A boy running, a boy trying to catch her, see. But they'd never catch her. Or you'd never catch the man. You'd always be 5 steps behind them. No matter what, you'd be 5 steps. But if you run up there even with them, you'd be even, wouldn't you? See? There wouldn't be any steps involved because you'd be running together, see? So that's what they're saying in this step 1 and 2, you know, based upon your number of poles, see? Now, in step 3, we want to know the slip value. So we take the synchronous speed times the slip. So you would have 1800 times 5%, and your RPM based upon the slip would be 90. Now, you would take the 1800, subtract your 90 RPM, and you're going to come up with 1710 RPM. You wouldn't have the 1800 RPM in step 1 or step 2 because you're running with 5% slip, whatever that may be. Now, more about slip can be studied in greater detail, you know, in the book that you see. So if you're interested in that, fine. If you're not, that's okay too. Now the solution, you'd have 1800 RPM is the synchronous speed. And the only motor I seen that would really do that was the synchronous that we used. And then the solution, then your actual speed would be 1710 or 1710 RPM would actually be the speed, excuse me. So that's how you would find it. Those are the formulas you would use if you're interested. But the main thing about it, usually, you know, you're going to see on the nameplate what your RPM would be. And then, of course, when you get in more detail of the book, you'll have different RPMs of motors, you know, based upon the way the motor's designed and so forth. So figure 14-13 is illustrating a slip of a motor at 5% where you would never catch the force of the magnetic field. You're always 5% below that strength of that field, so to speak.